I am really very happy to participate in your international conference in the chemical matters environment presentation. The title of this paper is Evzado as a no-toxic buffer layer for fabrication of CS thin film solar cells. Outline of this presentation starts by introduction, that method of preparation, after that the result, finally the conclusion. The copper indium dicyanide as a direct semiconductor useful for fabrication of solar cells, crystallized into cooperate structure, and the material has high optical absorption, convection, a good stability, create P and N type crystal. Attribute of a good buffer layers: good lattice matching property with absorbed layer, enable the formation of interface with low defect density, high transparency, and wide bandgap bottom material to allow photons to pass through the absorber layer, optimum thickness around 15 nanometers to avoid short circuit effect, high conductivity to minimize carrier loss, free form toxic element, possible component semiconductor as buffer layer as CDS, ZNS, SO, and other buffer layers. About CDS, conventional buffer layer, has the following disadvantage: presence of toxic element cadmium, band gap is 2.45 electron volt, limits the blue response of the photovoltaic cells. In the other side, ZNO is a perspective candidate as an alternative buffer layer, not toxic layer. Band gap is 3.1 electron volt to 3.7 electron volt. Enhanced the blue response of the photovoltaic cells, relatively cheaper and abundant. The preparation, the electrode deposition with 3 electrodes shown in figure 2, fluorine doped with dioxide FTO coated glass substrate were used as a working electrode. An acetate was to add as a complex agent. pH solution adjusted 2 to 2. The film were deposited for minus 0.8 volt. Coated temperature 350 for 13 minutes. There approximately equal to 2. The result of this structure is a good agreement with the data of the literature. D is equal 100 at 354 13 minutes and has high intensity of 113 peak. In the Some image of CS film is wide, very compact, and fairly. The aspiration spectra and band gap, as shown in figure 5, show a direct transition with band gap of 1.05 electron volt. In conclusion, CS crystal films were obtained by electrochemical deposition. All the films are tetragonal cooperate with forward orientation 112 direction. Crystal nearly 112 atomic ration. The surface morphology of all layers were wide, free, compact, and fairly uniform. Minus 0.8 volt is suitable for deposition of CS films into FTO substrate. PN junction between ZNO doubled fluorine doubled ZNO and the CS pattern device performance. The optical band gap was estimated by 1045 electron volt. Such band gap is highly beneficial for the solar cells application. Thank you for attention.